Hi, basic chemistry students. We are going to perform today the second experiment, which is the acid-base titration. The first step of the experiment is to take two masses of potassium hydrogen phthalate or KHP. That's why I have to prepare a weighing dish, noting on it that this is the first weight, which is M1. I put the weighing dish on the balance and I have to push star because in this experiment, in this step, I don't need the weight of the weighing dish. So I have to push star. I open my KHP bottle. I have to take a mass between 0.7 and 0.9 grams. I continue adding until I have a mass inside the range noted in the experiment. This is fine. I can have this amount as, and I have to note it as M1. I need this mass, so I have to note it M1 equals 0.716 grams. This is the lab report sheet. This is M1. I take a second weighing dish. I note it as M2 in order not to get confused between the two masses. I put the weighing dish on the balance. I keep adding until I reach a value inside the range. This is fine. Now I am done with KHP. I have to close the chemical bottle very well. I put it away. I note my second mass, M2 equals 0.771 grams. It is 0.77 grams. Now, to prepare the solution, I have to add the first mass to a first Erlenmeyer flask that I note M1 and M2 to a second Erlenmeyer that I note M2.
Yes.
I add M1 to the Erlenmeyer named M1. I take all the amount M1, and to make sure that I have taken the whole granules, I add 50 milliliter of water in the following way. Now those are 50 milliliter. I will take them with a graduated cylinder because this amount of water will not be included inside my calculation. So I take the 50 milliliter like this in order to be sure that I have taken all the way the granules. Now I can shake a little bit with my hand. Anyways, later on I will add a magnet bar to my solution like this by tilting the Erlenmeyer flask. And now I have to add 2 drops of phenolphthalein, the indicator. So the indicator, the acid-base indicator I'm going to use is phenolphthalein. I added 2 drops. I will do the same with M2. I will prepare the 50 milliliters. I will say a second time that I'm using a graduated cylinder because this amount of water will not be included into my later calculations. Now I am sure all the granules are inside the Erlenmeyer flask. Again, I will add 2 drops of my indicator, which is phenol phthalate. Now I have prepared my acidic solution. I will go to prepare the titrant, which is sodium hydroxide. Again, on the balance, I put some weighing dish, I push star. I have to weigh almost 2 grams of my sodium hydroxide pellets. This is sodium hydroxide pellets. It's a very hygroscopic material, that's why I have to take the amount I need and close the bottle very quickly. I'm not allowed to leave it open for a long time. This weight should be approximate. Why? Because I'm going to standardize my sodium hydroxide solution. This weight will not be introduced into my calculation because I'm taking almost 2 grams of sodium hydroxide. I have to dissolve this amount in a 500 milliliter volumetric flask. I introduce them like this, or I can use also a funnel, of course. Okay. Again, with distilled water, I have to take all the weighed amount. Of course, all our solutions in a lab should be prepared with distilled water, not with tap water. And this is a general rule to be used in all our lab work. So I will add a little amount of sodium hydroxide to dissolve the granules. And later on, I will add more distilled water to reach the mark of my volumetric flask. Because this is a 500 milliliter volumetric flask, I am allowed to do this. I can open the distilled water bottle and do this until I am very close to the mark. I have to reclose it again and adjust the mark with a dropper. Now I am very close to the calibration mark of my volumetric flask, so I have to use a dropper to adjust the mark of my volumetric flask. And as always, I should have the bottom of the meniscus formed by water tangent to the mark of my volumetric flask. This is distilled water, and I'm filling my volumetric flask with distilled water. Now, if you have a close look on my volumetric flask, the bottom of the meniscus formed by water with the glass should be tangent to the mark of my volumetric flask. Now, I close my volumetric flask. I homogenize it by inverting it like this. 1, 2, and 3. Now I can label it as sodium hydroxide, almost 0.1 molar, almost, okay? Because I'm going to standardize this solution. I label it and I put it next to the KHP solution. Now my solutions are ready for the standardization step. I will go to the burette to wash it and fill it with my titrant. This is my graduated burette. It is graduated from 0, which is up, to 50 milliliter, which is down. Everything I have to use the burette, I have to wash it first with distilled water. Of course, I have to put some waste beaker under it. I open the tap. I have to wash it many times with distilled water to make sure that I have a clean burette. And the last step is to rinse it with little amount of my titrant, with the solution that I will fill the burette with, which is the sodium hydroxide that I have, which is the sodium hydroxide which I have prepared. So I have to rinse my burette with little amount of my titrant. I have to take care not to form an air bubble inside the lower part of my burette. This is the lower part of my burette. Now I have a big air bubble here. I have to get rid of it. So I have to get rid of the air bubble formed here. That's why I open the tap and I have to do this to get rid totally of the air bubble. Now I got rid partially. I still have an air bubble over here. That's why I have to do this again. So now all the lower part of my burette is full of my titrant. I will now adjust the mark of my burette to 0 with the sodium hydroxide. I have to add my titrant little bit above the mark of the burette and then adjust it with the tap of my burette. To adjust the mark of the burette, first I have to remove the funnel. And I should have my eye at the same horizontal level of the burette and open the tap down. The same person should have his eye on the mark and his hand on the tap of the burette. And now I have the bottom of the meniscus tangent to the mark of the burette. Everything is ready to start my titration. The first weight of KHP that I have inside this Erlenmeyer flask, I have to put it under my burette, so I have to little bit adjust the burette according to the glassware I have. I put the Erlenmeyer flask at the center of my stirrer, and then I adjust the burette accordingly. Now, as the stirrer is plugged in, I can turn the stir on. We have to take care. This stirrer has 2 ports, stir and heat. So I have to put stir here. And now I can start my titration by adding my titrant to the KHP solution. Of course, as it is my first titration, I have to keep adding dropwise while having my hand on the top of the burette and my eye on the color of the solution. As you noticed, phenolphthalein is colorless inside the acidic solution of KHP. Now I'm adding the basic solution. So when the solution will be basic, the phenolphthalein should have the light pink color. I'm not searching for the dark pink color. It will be an exceed of the equivalent point. So I have to keep adding dropwise and having my hand on the top of the burette, my eye on the color to reach the equivalent point. Now it's almost 13, 14. I have to keep going on. This is your first titration, so you have to go again dropwise and slowly, not to go beyond the equivalent point. Now the volume is almost 18 milliliters. My hand is on the top. While titrating, I should keep my eye on the color because this is the shift that I am waiting for. I don't have to look away. Now, the pink color is appearing and disappearing very quickly, so I know that I am a little bit close to the equivalent point. Now the volume is almost 25 milliliters and the shift is not reached yet. Again, the color is appearing and disappearing very quickly. Now I am almost 30 milliliters. As you can see, the pink color is more clear now. So I have to go a little bit slower. So the pink color is taking more time to disappear when I have reached 31 or 32 milliliters. Let's wait. Okay, it disappeared. More, one drop. I have to wait few seconds until I see that if the color will disappear or not. So the color did not disappear. I have reached exactly the equivalent point, and now I have to, this titration is done. I can turn the stirrer off and remove the Erlenmeyer flask. This is the pink color I should have inside my Erlenmeyer flask. Now I have to get closer to my burette to get the correct and exact value of my titrant. If not, I will do a big error. Now I'm seeing the bottom of the meniscus exactly tangent to 32 milliliters. The burette is graduated from up till down, so now I am sure that this is 32 milliliters. Now I can note on my report sheet for M1 I have VE1 32 milliliters. Okay, I go to the second titration of KHP. That's why I have to get the magnet bar from inside of my first solution by doing this or that. Okay, I have to wash it with plenty of distilled water. Now I have a clean magnet bar that I can insert it inside the second weight of KHP by tilting the Erlenmeyer flask, and this solution should be discarded inside the sink. And again, I have to adjust the mark of my burette again to 0. Now, to start the titration of the second weight of KHP, I have adjusted the burette to the 0 mark. And now, as I know almost the volume of my titrant, I can go a little bit faster than the first titration. For example, I can go fast till 25 milliliters. Of course, I have here a different weight, so a different VE2. But I can go faster, for example, till 25 milliliter, then I go dropwise. I turn the stirrer on, and I'm adding my sodium hydroxide to the second weight of KHP. Okay, now I have reached 25. I have to go dropwise now. The color, the pink color is appearing and disappearing. Now it is taking a longer time to disappear. I am close to the equivalent point. Have to go slowly. One drop. One more drop. Is it the needed color? I have to wait few seconds until I see if the color will disappear or not. So the color has disappeared. I have to add one more drop just one more drop. Okay, this is one more drop. Few seconds. I think this is the equivalent point. Let's show you the color. This is the needed color at equivalency. Now I am done with the second titration of KHP. I have to take the magnet bar outside of the solution and discard the solution. Then I have to come to the burette to take exactly the volume of my titrant. Now I'm seeing it at 34.5. So some students make error by reading this value as 35.5. No, it is not 35.5, it is 34.5 because the burette is graduated from up till down. So 0, 1, 2, 20, 25, 30, 33, 34, 35, 34.5. So VE2 is 34.5 milliliters. I am done now with the part of the standardization. I will go to the second part of the experiment, which is the titration of a vinegar solution. Now we are going to perform the second part of our experiment, which is the preparation of the vinegar solution and titrating it with our titrant, which is still sodium hydroxide. To prepare the vinegar solution, I have to pipette 20 milliliter of a vinegar solution that I have inside the lab, and every time that I have to prepare a well-defined concentration of a solution, I have to use a pipette, not a graduated cylinder. And sure, I will not put the pipette inside the volumetric flask that contains vinegar. I have to pour some amount of the vinegar solution that I have inside the lab inside a beaker, and to dilute it 10 times. So I will pipette 20 milliliters and put them inside a volumetric flask of 200 milliliters. Same as I did the pipetting in the first experiment. I have to roll up the wheel of the probe pipette to suck up the vinegar solution. I should have my eye at the same horizontal level of the mark of the pipette. Now I am sure I have pipetted exactly 20 milliliter of vinegar, and I will put them inside a 200 milliliter volumetric flask. And of course this is a dilute acetic acid, otherwise I have to put little water inside the volumetric flask, and then I have to add the vinegar, because the general rule says that I never add water to acid, I add acid to water, and now I have to go up till the mark by adding distilled water. I am now very close to the mark. I am preparing a well-defined concentration of my acid. I have to take care not to go beyond the mark. This is exactly the needed amount. The bottom of the meniscus is tangent to the mark of my volumetric flask. I put the cap, and now I have to homogenize my solution by doing this. 1, 2, and 3. an exact concentration of a solution should be prepared inside a volumetric flask, not a beaker, not an Erlenmeyer flask. Now I have prepared my vinegar solution. I have to take 10 milliliter of the solution. That's why I have to pour some amount inside a beaker. I have to repeat the experiment twice. That's why I take little bit more than 20 milliliters. I have to use a 10 milliliter pipette. This is a 10 milliliter pipette, and inside a clean Erlenmeyer, I have to suck up 10 milliliters. So I go down to the level of my solution. Those are exactly 10 milliliters of the prepared vinegar solution. And now, this is the first solution. I have to add 2 drops of phenolphthalein indicator. This is the first volume. I will prepare a second volume the same way into a clean Erlenmeyer flask. I have to pipette 10 milliliter of the prepared vinegar solution. And empty my pipette inside. Two drops of phenolphthalein indicator. And now I can start my titration, the titration of vinegar with the sodium hydroxide solution. I don't know the approximate volume of NaOH, that's why I have to go dropwise from the first drop of titrant. So dropwise. Now the volume is almost 7. The color, the pink color is appearing and disappearing. The same as before, because I have a vinegar solution which is acidic, where the phenolphthalein is colorless, and I'm adding sodium hydroxide though, so I should wait for the appearance of a light pink color, same as the titration and the standardization of sodium hydroxide with KHP. Now the color is taking more time to disappear, so I am very close to the equivalent point. I have to add 1 drop of titrant, wait little bit, wait for the disappearance of color, and then add the next drop. Maybe I have reached the equivalence. I wait few seconds. I turn the stirrer off. Yes, this is the equivalent point because the pink color did not disappear. I have to go to the burette. I should have my eye at the same horizontal level of the burette and to read the correct volume, and 9 milliliters. I go to my report sheet and I note titration of vinegar VE1 is 9 milliliters. I have again to adjust my burette to do the second vinegar titration. everything is ready to do the second titration. Don't forget to insert the magnet bar. I turn the stirrer on. And now, as I know that 9 is almost the equivalent volume, I can go a little bit faster than the first titration till, for example, 6 or 7 milliliters. Then I go dropwise. The color is appearing and disappearing. The color is taking more time to disappear, so I have to add 1 drop, wait a little bit, and then add the next drop. Okay, I think this is the equivalent point. Let's wait a few seconds. Turn off the stirrer. Yes, this is the equivalent point. The volume sure should be very, very close to 9. Otherwise, I have to repeat a third time the titration and to take the 2 closer values. The volume is exactly 8.9 milliliters. So VE2 is 8.9 milliliters. Now I have all the data to do my report, and this is the end of our experiment.